Hello students. So now we will discuss about the unit 1 part 1 introduction of computer organization subject, and now we will discuss that how this unit provide us the overview of the computer organization systems, computer organization and computing systems. So it is all about the introduction. So the outline of this presentation is the main component of a computer, historical development first through fourth generation of the computers, Moore's law and the von Neumann and non-von Neumann models, and the evolution of the Intel x86 architecture. So we will discuss all these things, and we will learn that how these terms are important for us to understand and to develop the view and ideas about the computer organization. So there are difference in computer organization and computer architecture. So basically, computer architecture refers to those attributes of a system visible to a programmer, or put another way, those attributes that have a direct impact on the logical execution of a program. I am following the book of William Stalling, so you can also check the things from William Stalling for your reference, and I am also following this book and some of the internet resources. Okay, so it deals with what things we are going to deal with, right? What type of the architecture, what type of the designing, so what type of for what we are going to work, right? So this provide us the answer of this what question, right? And designing of computer is important. So designing of computer means when you need to design a computer, then you find the architecture, computer architecture. We must have the knowledge of the computer architecture. For example, that for a particular application, which type of processor or computing system we need to use, which for particular application, how much memory we need to deal with, right? So these things comes in computer architecture. Next, whenever we are going to deal with the computer architecture, in a designing of a computer, we need to deal with that which type of input and output mechanism is there, right? That it may be a simple button, and output may be a simple LED, right? And it may be a keyboard, and output may be a monitor, right? So these type of the things are important whenever we are going to discuss about the computer architecture. Next is designer point of view. So whenever I am going to deal with to design a computer, then I have to use a processor, I have to use a memory system, I have to use a input device, I have to use a output device, and which type of device I am going to use whenever I am going to design a computer, then it is a computer architecture. Okay, then we no need to deal with the computing. We don't need to deal with that how the programmer will work on these things, but a complete architecture I have to provide a programmer so that he can work on the things, right? So example of architectural attributes include the instruction set, that the number of bits used to represent various data types, for example numbers or characters, input output mechanism, and techniques for the addressing memories. So these all things are needed whenever we are deal with the computer architecture. In computer organization, there is a definition. The computer organization refers to the operational units and their interconnections that realize the architectural specifications. So we know that what are the specification of a computer system, and when we know the specification of a computer system, then we know that how can we work on this particular computing system. For example, whenever we know about the early computing system which can handle 32-bit micro operating systems, right? Now these days the computing system can handle 32-bit as well as 64-bit operating systems also. So we must know the specification of the computer hardware whenever computer organization comes in picture. So next is how it provides us answer of how we will work on the computing system, right? Next is logic and circuits. So in computer organization we will deal with the logical circuits and logical units and circuits. So we know that what are the basic units of a logic circuit. We should know that how it is working. We should know that how my data will be processed in a logical system. So these all things will be provided by the computer organization. Okay, programmer point of view. So if we deal with a programming, then we should know that what are the architecture of a computer, how the things are organized in a computing system. For example, we know that integer takes 4 bytes. So the memory location or located for a integer will be 4 byte. So it is always according to the programmer point of view that how he relates the things with the computing system. Example is organizational attributes includes those hardware details transparent to the programmer such as control signals, interface between the computer and peripherals, and the memory technology. So computer organization provides us all the details inside of a completely interfaced computing system. I am saying completely interfaced computing system because the processor can be interfaced with the input unit, output unit, storage unit. These all structural structures are to be known by the engineer, and this is the computer organization basically. So the main component of the computer, what are the main component of the computer? So in a William Stalling book, it is referred as a structure and function basically. That whenever we are going to understand a computing system, then we should know that what is the structure of a system, what is the function of a system, right? So we should know about both the things. So a computer is a complex system. Contemporary computers contains millions of elementary electronic components. So it is a basic definition. It is a very basic definition of a computing system or a computer. Due to complexity of the computer, the key is to recognize the hierarchical nature of most complex systems and including the computer. The designer is concerned with structure and function. So I have already told you that whenever we are going to deal with a designer, right? So designer will understand the computer by two things. So one is the structure and another is a function. So the way in which the components are interrelated, this is your structure, and in function, the operation of each individual component as part of the structure. So, okay. So these are two things by which a designer must know about the things about a computing system. Okay. So in a structure, that how much the memory, what is the speed of the processor, how the input and output devices are interrelated with each other. In a functioning point of view, when a programmer sits on a before a computing system, then he should know that how should he use the memory so that the memory can be consumed very less, right? How the complete interfacing of the computing system will be happen. So these all things must be known by a designer. So functional description I am giving for a computing system is like that operational environment, source and destination of the data. So if I am providing some data to the computing system, and if it is manipulating the data and then it is providing back the results or complete information to us, then it is a operating environment, right? So it is bidirectional, right? At one side it is a source, at one side it may be the destination, right? So next is data movement. It is a functional view of a computer. So next is data movement apparatus. So data movement apparatus are maybe your you can say the input output systems, right? Next is your control mechanism. Whatever the data comes, control mechanism will decide that what to do with the data, whether it to be stored in the storage device or it to be processed further, right? So the computing system works with the data in different way, and the whole things will work in these 4 blocks, whatever you are saying here. And let's see that what's in the function. Both the structure and functioning of a computer are in essence simple. Figure depicts the basic function that a computer can perform. In general terms, there are only 4 functions, and these functions are data processing, data storage, data movement, and control. So these things are provided in this diagram. Now in a functional description, that how it works actually. So we know that from the outside world we will take some data, the movement of the data will be happen, and the movement of the data will provide some movement of the data will provide us the control, and the data is provided to the control. That may possible that if I am providing some data to the control, for example, if I write a program in a C that added 2 numbers, then it will take 2 numbers, it will add the things, and it will provide us back. So it is an example of this, right? So it may be possible that the data may not be used to be storage and process further, right? So it will just control the things, right? Next, another example of this figure is whenever we need to control my devices or input output devices, then control mechanism will be interrelated with these two within these 2 blocks only. Okay. Next is movement, control, and storage. This arrow shows us a bidirectional way, and data will come to the control, and it may possible that we need to store the data, right? And for example, if I downloaded some movie from the sources from the outside world, then control will shift the data to the storage, and it will be stored in a memory. Next is the storage will take some data, and the data is through control, it will processed and then again stored to the storage device. For example, many times computer works for itself. It does not take data from outside. Whenever we have an operating system, then operating system works for itself and store the data for itself. So this is the one of the architecture, one of the you can say processing mechanism. And another is we have the data from outside, and it will be controlled by the controller, and then it will be processed and then go to the storage, and it may possible that the data is captured again and it will be provided to the outside world. So in all these things we have one thing in common, and it is control. So control will control all the activity, right? So you can say it is a brain, and it will control all the things whatever we have in a computer. So control is a most important part of a logic design, right? Next is, in a structural point of view, how we can see the computing system. So in a computing system, it can be seen as a storage and a processing system. So there are many peripherals which are attached to it, and these peripherals may be input and output devices, maybe Ethernet, maybe internet, maybe Wi-Fi, maybe your mouse, maybe anything, maybe your computing system, maybe your printer system, maybe your scanner. So these peripherals and Ethernet, so these peripherals are controlled by means of the are interfaced with the computing system. Computer system has two things, one is a storage and one is the processing, and another thing which is important for us, and it is a communication line. So some of the words I have used here, for example, internet and Ethernet, UART, right? UART is a universal asynchronous receiver transmitter circuit. So these things are used with a with a computing system. So let's discuss one of the thing. If I have a very simple computing system, for example, if I want to glow a LED, right? If I want to glow a LED only on pushing a button, right? So whenever I have a it is my CPU, it is my control unit or CU, I am writing here, it is my CU, right? Sorry for the CU. So next I am interface it with a simple button, right? It is your VCC, or power supply. It is a button. It is very simple computing. It is a very simple computing. And here you have one LED. One LED. And you need to just glow this LED. So it is very simple computing system. So when you push this button, then this LED must glow, or it should take a sensor data, it should take some it should communicate with something. So these are possible application of a computing system. It is a very simple computing system. When this pin is pushed, then the LED must glow. So it is taking data from this pin and it is providing data to this point, right? So it is processing on the system. It may possible that you say that store the you can say store the status of this pin where this push button is connected for 5 values. So it will start to store the data for 5 values. And now if you say check the average of this, if average of the push buttons is higher, is logic high for more at more times the logic high, then glow the LED, then it is processing. So this is a simple computing system, and how it works I have told you just is an example. So you can check it, and you are using whatever you have, your PC, your laptop. It is a very high functional general purpose system, and these general purpose systems are used for your computing system, and you will learn all these things, that how this computing system works actually. So in a structure description, I will tell you that there are this is my computer, right? In this computing system we have input output device, main memory, and system bus. System bus is a bus which interconnects CPU, input output devices, and main memory. So system bus has a CPU, and this CPU has a further description as a registers, ALU, internal bus, and control unit. So next further this control unit is divided into sequencing logic, control unit registers and decoders, and control memory. Now I will explain you that main memory, maybe your RAM-ROM is your main memory. Input output is so simple keyboard or mouse is your input, and your monitor is your output device. Or system bus, which is interconnecting all the things. CPU is a control unit, and you can say central processing unit. So central processing unit has registers further you can say are used for the storage of the data for temporarily purpose, and ALU arithmetic logical unit, and ALU is used for the arithmetic and logical unit for you can say calculation and manipulation of the data. Internal bus is again used for the interconnecting all these units between among each other. Control unit further has another things that how ALU and register will work, it will decided by control unit only. So control unit further divided into some parts. One is sequencing logic, and control unit registers and decoders, and control memory. This control unit does not have the bus. Okay, so that's how the top level structure of the computing system is defined. And whatever I have defined I have discussed with you is summarized in this text, so you can read this text also. So it's enough for this lecture. Thank you.